Hi, welcome to our last level 1 tables, equations and graphs video. We got there. Now this video still continues focusing on exponential graphs, and we're going to use them to solve some common problems that could come up in assessments. Right, example 1, stomach bugs racing through a school community. The school's got 1,490 students. A model that represents how many students are catching the bug per day. A mathematical model is n equal to 1.6 to the power of d plus 3. Now, n is the number of students catching the bug, and d is the number of days since the bug was identified at the school. Right, here's our first question. How many students caught the bug on the first day? So our model, n equal to 1.6 to the power of d plus 3. Since we're talking about the first day, d is 1. We're going to substitute 1 and go 1.6 to the power of 1 plus 3 more, and that gives us 4.6 students. Now, we can't get 0.6 of a student, so we're going to be sensible. The 0.6 means round up to 5 students, and we'll say there are 5 students that caught the bug on the first day. Right, another question. How many more students caught the bug on the 11th day compared to the 10th day? Well, we're going to do a similar thing. We're going to start off and substitute in 11 for d, 1.6 to the power of 11 plus 3. That gives me 178.9218604. We can't get decimals for students, so once again, we're going to have to round up to 179 students. We'll do the same for the 10th day, 1.6 to the power of 10 plus 3. That gives us 112.9511628, but we have to round it because it's the whole number of students. We'll round it to 113 students on the 10th day. So to work out how many more, we just need to subtract those two numbers to work out the difference. 179 minus 113 means there were 66 students, more students, that caught the bug on the 11th day compared to the 10th day. Okay, here's example 2. A car that was bought brand new for $20,000 decreases by 5% each year in the price as it gets older. So the question we're going to solve is how much is the price of the car after 8 years? Now, here's the exponential mathematical rule to do with the price of the car. The price P is equal to 20,000 because we bought it for brand new for 20 grand, multiplied by 0.95 to the power of n. Now, where did 0.95 come from? Well, think about if we have a car that's 100% and it decreases by 5%, then that means we've only got 95% left over. So the 0.95 means every year we're working out 95% of that current value. So now we've got the mathematical rule. Let's work out the price of the car after 8 years. N represents 8, so let's substitute in 8 and go 20,000 times 0.95 to the power of 8, and we get 13268.40863. Because it's to do with money, we'll round it to 2 decimal places, but actually I'm going to be more sensible and say after 8 years, the car is now worth about $13,270. We don't say, oh, how much do you want to sell your car for? Oh, $13,268.41. That's a little bit weird, so we'll round it to $13,270. All right, our last example is number 3. This is to do with the number of visitors to a theme park, and this is decreasing. Maybe we're having a bad run and we don't have many visitors coming. A model to estimate the visitors per year, mathematical model, V is equal to 20,000 times 0.9 to the power of n minus 3. Now, V is the number of visitors per year, and n represents the number of years. So you have the question we're trying to work out. How many years will it take for the theme park to have less than 10,000 visitors per year? Now, next year, if you continue mathematics, we're going to show you a really cool trick that can work this out exactly. But for now, we're going to play a game of just guessing and checking. 20,000 times 0.9 to the power of, now I'm going to go bracket n minus 3, so I'm going to guess 5 minus 3. That's 16,000. No, that's not what I want. So let's go 20,000 times 0.9 to the power of bracket 9 minus 3. No, not quite there. So when I get up to 10, I know that I've got under 10,000 people. So it's taken me 10 years to get less than 10,000 people. So I can answer the question, it will take 10 years for the theme park to drop below 10,000 visitors per year. Awesome. Thanks so much for watching.